Hello, everyone. Our presentation today is about the cognitive capacity and earning capacity. My name is Zhongjin Dai. The speaker should be Professor Shuhen Chen, but he encountered some technical problem with his computer, so he could not record this presentation by himself. Since I've been working very closely with Professor Chen on this topic since 2009, so please allow me to present this topic for you. We are going to present an experimental study on economic inequality. The inequality means that the people has different income or wealth in the economy. At the beginning, I want to present two figures. The first one is proposed by Norton and Riley. You can focus on the upper part, the actual distribution of wealth in the United States. If you rank all the population by their wealth, and the richest 20% is represented by this blue bar. As you can see, the richest 20% owns more than 80% of the total wealth. And the lower 40%, their total wealth can hardly be seen in this figure. So this figure really reminds us the serious wealth inequality in the United States. The second figure is known as the Great Gatsby curve. It illustrates the relationship between income inequality and income mobility. The x-axis represents the income inequality. The larger the value, the less equal of the nation's income. The y-axis stands for income mobility. It is measured by the influence of parents' income on children's income. So the higher the value, the greater influence of parents' income on children's income. As you can see that the UK and the US stands on the upper right corner of this figure. That means these two nations has not only a very large income inequality, but also their income mobility is worse than other countries in the same figure. Inequality is an important issue in economics. So many economists have proposed different theories or factors to explain the source of economic inequality. In this research, we are going to focus on one specific factor of them. That is the cognitive capacity. So at the beginning, we will introduce very briefly the literature, especially the empirical evidence and laboratory evidence on this issue. After that, we will introduce our experimental design, followed by the experimental result. Finally, we will make our concluding remarks. Economists have recognized the importance of inequality a long time ago. The very famous 19th century economist Pareto has studied this issue in detail more than 100 years ago. He collected data from European countries as well as in the US. He found that the most probable reason behind inequality is not the social systems, because no matter you are in the democratic nations or in an authoritarian nations, there's always inequality in income or in wealth. He thought the most probable reason is the differences in human factors, such as physical factors and other characteristics such as intellectual qualities, morals, diligence, etc. He called these differences in human factors social heterogeneity. And he further argues that this social heterogeneity will lead to economic and social inequality. After several decades, the inequality problem attracted economists' attention again. They found that the intellectual quality is related closely to the performance in the individual as well as in the aggregate level. For example, Herrnstein and Murray 1996 has shown that IQ is related to people's social performances. There is another line of research showing that statistically, IQ can be used to explain economic growth and also the differences in national wealth. Talking about income dispersion, a lot of econometricians have used empirical data to test the relationship between cognitive capacity and the income dispersion. Here, the cognitive capacity is measured in terms of IQ scores or SAT scores or other measurement that you can collect it from students in schools. They use panel data and found that IQ scores or other measurement does play a role in determining people's income after graduation, although it is not the most important factor. Another interesting issue is about people's investing behavior. Here we can see three studies using European data. They've shown that people with higher cognitive scores participate more in stock markets than people with lower scores. The studies in 2012 further show that people with higher cognitive scores are capable of choosing stocks with higher financial returns. If we move on to people's behavior when interacting with others, experimental economists have found that people with higher cognitive scores perform better in cooperation and coordination games, and people with higher scores are more generous. Also, subjects with higher scores have deeper depth of reasoning, and also they made less mistakes when interpreting complex interaction problems. So what can we do after we have seen a pile of study related to cognitive ability and economic performance? Here we ask a question that is not perfectly answered by previous study. To be exact, we want to know the relationship between cognitive ability and people's performance in market transactions. By market transactions, we are talking about people's buying and selling behavior in the very common financial market trading mechanism, that is the double auction market. So we can jump to our experimental design. Our experiment is composed of two major parts. The first one is about the trading environment, which is the double auctions. The second one is how we can measure subjects' cognitive capacity. Here we measure their working memory capacity, or WMC. The double auction is the core trading mechanism of many commodities, including financial assets. It is called double auction because many buyers and sellers meet together to trade a common good. In our experiment, we have 4 buyers and 4 sellers in the market. Among the 8 traders, only one of them is a human subject. The others are computer agents. So every human subject will have to compete with computer agents in his or her own market. So in our experiment, human subjects will not interact with each other. We have 2 types of computer agents. The first one is called truth tellers. They are called truth tellers because they send bid or ask to the market according to their true evaluation of the commodities. For example, a truth-telling seller will send ask equals to his production cost to the market. The second type of agents are called software strategies. We collected 7 strategies from the economic literature, and these strategies are designed so as to gain as much profit as possible. So we have 2 treatments in our experiment. In experiment 1, human subject has to compete with truth tellers. In experiment 2, human subjects will play with software strategies. We assign 4 token values to every trader in the market. These token values can be regarded as reservation prices for buyers and marginal cost for sellers. For example, if a buyer has a reservation price of 90, if he can buy the goods from market with a price of 60, then he makes a profit of 30. On the contrary, if a seller has a marginal cost of 10, and if he can sell the item with a price of 25, then he makes a profit of 15. In any market, if the highest bid from buyer is larger than the lowest ask from the seller, then traders who send those bids and asks can make a transaction. And the transaction price will be the middle of the highest bid and the lowest ask. On the other hand, if the highest bid is smaller than the lowest ask, there will be no trade, and traders have to send their bid and ask again in the next step. Since every trader has 4 token values, and we have 4 buyers and 4 sellers in the market, there will be totally 16 reservation prices from buyers and 16 marginal costs from sellers. These 16 pairs of values can be used to plot the demand and supply curves in the market. As you can see in the slide, we have 3 different types of market arrangement in our experiment. The left one is market 1. If buyers' bid and sellers' ask equal to their reservation prices and marginal cost, then in theory, there will be only 8 tradable units in Market 1 because there are only 8 reservation prices from buyers higher than the cost from sellers. In Market 2, in theory, there are only 4 tradable units in the market, which means that there's only 1 tradable unit for each trader to make profit. The trading opportunity in Market 2 is much less, so Market 2 is tougher for every trader. Similarly, in Market 3, there are 12 tradable units, so Market 3 is relatively easy for every trader compared to Market 1 and Market 2. In this slide, we demonstrate all the reservation prices for all traders in our 3-market arrangement. Every trader has to trade from token 1 to token 4 sequentially. For buyer, the token values are listed from high to low so as to mimic the diminishing marginal returns. For sellers, the token values are from low to high so as to mimic the increasing marginal cost. We use S-shaped arrangement so that every trader has the same potential in terms of their profit and trading opportunities. At the beginning of each experimental session, every human trader is randomly assigned as one of the buyers or the sellers, and he or she has to play from Market 1 to Market 3 sequentially. This snapshot illustrates what subjects could see in their computers. Every subject can see their identity as a buyer or a seller. They can also observe their reservation prices from the screen. They can also have access to the whole profile of trading history in the interface. As they can retrieve this information anytime during the auctions, they don't have to memorize any of them. What they need to do is to manipulate this information and calculate in their minds to find out the best trading strategies. And that has something to do with their working memory capacity. Our experiment took place in National Chengchi University, and we used monetary rewards as the incentives for our subjects. And most of our subjects are undergraduate students, and part of them are graduate students. We have 173 subjects for experimental 1, and coincidentally, we have the same number of subjects for our second treatment. After the experiment, we have to measure subjects' performance. In this study, subject performance is measured in terms of profit index. And profit index is calculated as the actual profit earned in the market over the potential profit. The potential profit is defined as the profit for each trader if every trader's bid and ask equals to their token values. So if your profit index is less than 100, that means your strategy is worse than doing nothing. By doing nothing, we means that you don't use strategy at all. You simply send bid or ask according to your token values. The second important part of our research is how we measure subjects' cognitive capacity. Instead of IQ, which is a very general measurement of intellectual quality, we choose to use working memory capacity. The reason we choose WMC is because, according to psychologists, it has anything related to successful reasoning, decision-making, and action planning. Also, experimental economists has found that WMC is important to many behavior in games. In our experiment, we use 5 different battery tests to measure subjects' WMC. This test is proposed by 4 psychologists, and one of them is our co-author. In what follows, we are going to introduce our experimental results for Treatment 1 to Treatment 2. Treatment 1 is a simple environment in which human subjects were playing with truth-telling agents. Truth-telling agents' behavior is predictable because their bid and ask equal to their token values, so we call it a simple environment. Treatment 2 is a sophisticated environment because the agents are computer software strategies, and they will change their behavior over time so as to gain as much profit as possible. So we call it a sophisticated environment. So we begin with treatment 1. The first question we have here is whether WMC can explain subjects' final performance. By final performance, we mean subjects' performance in the last period of each market environment. We have 6 repetitive periods for each market environment so that subject has a chance to learn a better trading strategy. We use a linear regression model to express this question. The dependent variable is the profit index of each subject. The explanatory variables include subjects' working memory capacity and the list of dummy variables indicating their gender, their role in the market, whether they have experiences on online market and financial markets and other auction markets. The last dummy variable is whether subject expressed the need for paper and pencil during the course of the experiment. Here are the results. After controlling other factors, we found that WMC is still extremely significant in predicting subjects' final performance in all 3 market environments. Our next task is to trace subjects' performance over time. We divide our subjects into 2 groups, subjects with higher WMC score as the high group and subjects with lower scores as the low group. This figure demonstrates both groups' average performance over time. We can easily observe several points. The first one, the high group outperformed the low group in every period of every market. The second one is that no matter how hard the low group try, their performance index is lower than 100 from the beginning to the end. That means they can actually do better by giving up their strategies. They can do better by simply use their token values as the bid or ask. Also, we observe that there is a learning trend for both the high group and the low group. As you can see, there's a positive slope for both lines. And the gap between the high group and the low group seems to shrink over time. So a natural question is that after a while of learning, is it possible that the low group can capture the performance of the high group? To provide concrete support for our visual observations, we run statistical tests on whether both groups' performance are identical. The result is that the high group's performance is indeed better than the low group in most periods of all 3 market environments. As to learning, we define learning as the improvement from period 1 to period 6. As this table reports, both groups exhibit significant improvement during the course of the experiment. That means they do learn. But if we compare the differences between their improvement, the differences is not significant, which means that the low group did not learn faster than the high group. That's probably the reason why they still cannot capture the high group even after 6 periods learning. Here we want to provide a simple explanation for what's happening here. This table illustrates the strategic space for buyer 1 in the market. The strategic space is consisted of the timing of the bid and the value of the bid. The optimal strategy is to send bids of 371 in the 4th trading step for token 1, and then followed by the second bid of 357 in the 8th trading step for token number 2. This optimal strategy will bring you the maximum profit of 71. And subjects in the high level, in the high group, many of them can discover this optimal strategy. But for the others, many of them are trapped in local optima. We now move on to experiment 2, which is a sophisticated environment where agents will adapt to the environment and change their behavior over time, so their behavior is not easily predictable. Following the same logic, we now test the linear relationship between WMC, other factors, and the profit index. It turns out that WMC is still significant in predicting the subject's performance in Market 1 and Market 2, but not in Market 3. Another striking difference from Experiment 1 is that experiences in financial market now plays an important role in all three market experiments. Our explanation is that Experiment 2 is more sophisticated in the sense that subjects' competitors will change their behavior over time, so it's closer to real market. It is because of this that experiences in real financial market will be very helpful when subjects try to develop their own heuristics when making trades in the market. We now follow the same analytical steps of experiment 1. In these three figures, the average performance of the high group is always above that of the low groups. Statistical tests also confirm this point. High groups' performance is significantly higher than the low groups in most periods of all three market environments. As to the learning behavior, again, both groups demonstrate significant improvement during the experiment, except for the low group in Market 3. If you compare both groups' improvement, the differences is not significant, which means that the low group still cannot catch up the high group after 6 periods learning. We are now going to compare the result from both treatments. Remember that experiment 1 is a naive and unrealistic environment in the sense that subjects' competitors are truth-telling agents. Their behavior does not change over time, and they are easily predictable. Experiment 2, on the other hand, is more realistic. Human subjects' competitors are computer agents who are adaptive, and they are changing over time. It's not easy to predict their behavior in the next period. As a result, the differences in experienced subjects and experienced subjects' performance is not significant in experiment 1, but in experiment 2. Experienced subjects do have a significant advantage over inexperienced ones. To illustrate these 2 points, here is a concrete bidding and asking pattern from an actual experimental tournament. The left panel is the actual bidding and asking pass from period to period in experiment 1. Because truth-telling agents' behavior does not change over time, so the actual bidding and asking paths are quite stable from time to time. On the other hand, in experiment 2, because computer agents' behavior is adaptive, so the actual bidding and asking paths change a lot from period to period. Most importantly, their behavior depends on your own behavior. So it is very hard to predict their behavior even if you know their strategy. So this is what we call a complex environment. So how do subjects adapt themselves in different environments? It turns out that they rely on different aspects of WMC in different environments. Remember that we have 5 different test batteries in our WMC test. Each test battery measures different functions of our WMC. By using stepwise regression, we are able to identify different factors in different linear regression models. For example, in experiment 1, the scores from send span, operation span, and memory updating span are the only important factors of WMC that can use to predict subjects' performance. On the contrary, in experiment 2, SSTM scores are the only important factors of WMC that can be used to predict subjects' behavior. To give a quick summary, when facing truth tellers, which is a simple environment, subjects rely more on the storage and transformation function of their WMC. On the contrary, when facing trading strategy, which means it's a more complex environment, subject relies on only the coordination function of their WMC. So we now goes to our concluding remarks. Our first finding is that working memory capacity is an important factor in predicting subjects' performance in almost every market experiment. So what if you don't have a large working memory capacity? You're lucky because if you are in the complex environment, experiences will help. The third finding in our research is that different trading environment demands different functions of working memory capacity. Finally, there are still a lot of questions to be answered regarding the relationship between cognitive capacity and economic performance in the market. It is important to know that how this relationship will impact our economic theory and the importance of its policy implications. And we hope that we can contribute more in the future. Thank you for your listening.